as we finish up this unit, this is lesson 4. We're going to talk about kind of sample sizes and populations and selecting conclusions and biases. So a population is like the entire group or the entire set of numbers, and a sample is a smaller, more of like a subset of that. So to select your sample, you may have heard of like sample size or something like that. There's various or differing methods that you can do to select your sample, and some work better for other situations. Some are more accurate. So one example is a self-selected sample, which is this first example here. And it's basically asking for volunteers. So again, hey, I need 10 citizens to come to City Hall and tell us what you think. So that's one way. Again, may not be the most random. In a systematic sample, a rule is used to select members of a population, such as selecting every other person. So if you were able to create a list of people and you said, I created this list, it's accurate, I'm just going to go every other. A convenience sample is something, like the name suggests, is just very easy. So you might say the first 10 people that show up get a prize. I'm going to do that. So that's how they selected, is just by ease. And then in a random sample, you may select a member, and each member has to have the same chance of being selected. So you're going to have to classify a few of them. So if we get a situation here, let me copy it in. Let's say that we have a baseball. Oops, let's see here. Perfect. Let's say that we have a sports writer who wants to survey college baseball coaches about whether they think wood bats should be mandatory throughout college baseball. Identify the type of sample described. The sports writer contacts only the coaches that have that he has cell phone numbers for in order to get quick responses. This to me would be a convenience, because again, he's not getting everyone's phone number. He's just trying to get the quickest poll that he can. The sports writer mails out surveys to all coaches and uses only the surveys that are returned. This again would be a self-selected sample, because again, the participants chose whether they were going to mail it back or not. And so this kind of leads us into our next point, which is about bias. So a sample that overrepresents or underrepresents participants, guess it's one word. As part of the population. So if it is over-representing or underestimating, we're going to call it biased. And this is representative of the population. Representative of the population. So we want unbiased. We do not want to be biased in our surveys, in our samples, because our results won't be accurate if we have bias. So if we take an example, we say the manager of a concert hall wants to know how often people in the community attend concerts. The manager asked 50 people who are standing in line for a rock concert how many concerts per year they attend. Of course, that's going to be biased because the people are actively going to a concert. So it's more likely that they would go to other concerts or more concerts, whereas he would never, if you only ask people at concerts how many concerts they go to, you'll never get someone that says nothing, or you'll never have someone that says 0. So you are definitely overrepresenting concert goers. You're leaving out groups. So that would be, again, an example of a bias. So that concert manager should choose his sample not at a rock concert. He should choose his sample some other way. So one of the ways you can do that is through random sampling. So if we take this situation, let's say that you are a member of the prom committee. You want to poll members of the senior class to find out where they want to hold prom. There are 324 students in the senior class. Describe a method for selecting a random sample of 40 students. So what you would do is you would make a list of all the students. Maybe it's alphabetical. You're going to assign a number from 1 to 324 to each student. So each student gets a number, and then you're going to randomly pick 40 students. Now there's lots of ways that you can do random, but given that it's we are advanced in our technology, there are plenty of random number generators out there for free. So if I look, again, all I typed in this website, random.org, it's a pretty good website to generate anything random. I chose, again, free service numbers. I went to the integer generator. And so we want 40 numbers between 1 and 324. And I'm going to get my numbers. All right. So now I would go back to my list. I'd go back to my list and I would find which of these, what student was 136, what student was 300, what student was 269, and then I would ask them for their opinion. So I would use randomness. I would use this to create an unbiased sample. I didn't have any control over what numbers were going to be picked. And then one of our last ideas is with sample size is a margin of error. So again, we want to have a small margin of error. So let me crop this and then we'll get it. There we go. So we need to have a large enough sample size, because the larger it is, that your margin of error decreases. So like the example states, if 40% of people, and this again, you'll see this a lot with like politics on the news, they'll say, hey, we think 40% of people are going to vote a certain way, but there's a 4% chance of error or margin of error. So that means anyone from 36 to 44% could actually be voting for that person. So let's do an example. Let's try to get, there we go. All right. Media survey. In a survey of 1,100 people, so fairly large sample size, 52% said that television is their main source of news. What is the margin of error for this survey? So again, the margin of error, if we had one person, if we look at our formula here, equals plus or minus 1 over the square root. My number was 1,011. So that means 1 divided by the square root of 1,011 is approximately 0.031. So again, whatever I decide my, so for 52%, I would say, all right, I don't necessarily want this as a decimal. I'm going to multiply it by 100, which moves this. So I would say that this is a margin of error of about 3.1%. So if I take my 52% and I add 3.1%, my high end is going to be 55.1%. And if I take 52% and subtract 3.1, I'm going to get 48.9. So I would say that given interval that is likely to contain the exact percentage, I would say that anywhere from 48.9% to 55.1% of people, according to this data, would get their news from the TV. Margin of error, sample size, bias, randomness. Yeah.